sorry. I wanted to get crushed. I was going to pick it up, I was just waiting.
So it's like
All right, how's it going, guys? This is Blockchain 101, a blockchain overview. I started already. A blockchain overview, and I'm just going to be generally speaking about blockchain, blockchain technologies, how it works, as well as some other things, including Oracle blockchain technologies and public blockchains. So this is going to be kind of an overview. I'm going to have a couple more other series that's going to go more in depth. So if there's like gaps, things that are missing, just be aware that I'm going to have a couple more series. I wanted this kind of be general, kind of level set for a lot of people, and a lot of people don't know what it is. Some people do know what it is. Some people are heavily into blockchain and blockchain technologies. So I wanted to kind of just cover all the bases from here and kind of give you a kind of an understanding, a general overview of kind of how it works. So starting off, blockchain is kind of a tough technology to talk about because there's lots of angles, lots of aspects. If we were only to talk about Oracle blockchain, it'd be just a little bit simpler, but I want you guys to be more well-rounded in terms of blockchain. So obviously you guys know me, I'm Ilya, one of the solutions engineers here. I've been doing app dev, blockchain, and cloud technologies here for a couple years now. I went to VCU for electrical engineering. I went to George Mason for finance and business. And I've been working here, working at a couple of startups. My past experiences include working at the Department of Defense doing anti-nuclear implementations in finance, as well as working with some small startups in entertainment here in DC as well as LA. I wanted to introduce to you also, actually, I've got a QR code, so if anybody needs my information, you can just scan it, because QR codes are cool, because you know blockchain. But I wanted to introduce to you guys also Chad Blickenstaff. I work very closely with him on a lot of things.
Yeah, so Ilya and I had this idea of kind of bringing together the technical side with the business side of things. It's definitely on board. A little bit about me. I recognize some of you from downstairs when I was at VDC. I'm now on the LAN team, focusing on our autonomous offerings. Kind of how I fit into the blockchain space is I went to UCLA just over the 405, and we were actually the first school to have a blockchain engineering course in the entire country. So I joined up with the blockchain at UCLA, and it's early on. And I'm our director of partnerships. One of the partnerships that I helped procure was with the Mouse Belt Accelerator. Basically, they just gave us a bunch of money and said, hey, go build something cool with blockchain. That's led to some additional funding, and we're actually working on some different projects with some different blockchain languages. Apart from that, that kind of led me to being a technical advisory board member of a blockchain conference that's held at UC Irvine. Spoke with a bunch of startups, enterprise blockchain type people, and that's really just how I fit into the space. And also, I do, this is a hard stop for me, but I do want to introduce myself to y'all, and if you have any questions, feel free to reach out.
So Chad is on the sales side and the business side. Obviously I'm working more on the technical side, but we've actually done some events together. We work closely with the project manager for Oracle Blockchain. And we're also going to be starting an Oracle blockchain group. We're going to be having a meeting next week, and I'll talk about that a little bit later. But I wanted to introduce you to him. So if you guys have any sales questions, anything, the business side of it, he's going to be kind of the go-to person as well.
I'll see you later.
Cool. Thanks, man.
That's easy.
So quick agenda. So what is blockchain? How it is technically different. The types of blockchains, business in the context of blockchain, key properties. And then I'll do some hands-on stuff with public blockchain using vending machines, as well as going over briefly the Oracle blockchain platform. Then we'll have some questions and then have some follow-up things. So you guys are probably thinking, what is blockchain? Yes? No? Everybody knows what blockchain is? We're done here?
What is blockchain?
Very, very interesting question. A lot of people have a lot of different concepts of blockchain, what it is. So what is it really? So blockchain was originally thought to have been invented by the person named Satoshi Nakamoto. This could have been a group of people, or this could have been one person. Actually, the identity of Satoshi Nakamoto is unknown. Blockchain is a new way of interacting and creating and recording data and transactions. Blockchain has also enabled the creation of cryptocurrencies, which are digital intangible assets, and payment methods. Who here knows what cryptocurrencies are? Everybody? Okay, cool. Good. So blockchain is a decentralized way, a distributed way, and oftentimes public way to have a digital ledger to record these transactions, and also a way that these transactions and records cannot be altered retroactively. Blockchain basically changes how we do business and how we interact with data. Current approaches to how we interact with, how we create business transactions, we use an intermediary. We use Visa, we use a bank, we use various intermediaries in order to record these transactions and have these transactions processed. So that kind of we have a problem with that because there's lots of issues. First of all, there's reconciliation costs. It's error prone, and also there's latency. I'm sure you guys have tried to send some money through a bank or maybe even PayPal, and you guys have incurred the fact that you have to wait 3 days. With blockchain or blockchain technology, it's very immediate because of the way that the technology is formed. Thanks to blockchain, businesses will no longer have to depend on intermediaries. You don't actually have to work through an intermediary to have all these records be recorded. You don't have to actually trust anybody that you do business with, meaning you don't actually have to know how much is in their bank account. You don't actually have to know who they are, what they do. You don't need any of this information, the way that this technology is created. I'm sure, again, you've tried to send money through PayPal or receive it. You have to put in your social security number, your ID, your address, etc., etc. With blockchain, you don't have any of that. And I'll go more into detail with this. And so you don't have to worry about the validity of the transactions because the transactions are very secure. So you're asking me like, all right, man, that's a lot of fluff. Like, but really, what is it? Right? No?
Yeah.
Well, actually, this is how it works. I just wanted to throw this chart up. I'm not going to go through all of it right now, but I wanted to kind of throw this chart up and just showing you kind of like the overview of how it actually works. There's lots of different components in here. Today, I'm just really going to be talking about recording transactions on the blockchain. Later in the other workshops, I'll talk about consensus algorithms, smart contracts, modifying smart contracts, programming smart contracts, and even programming the blockchain using a language such as JavaScript. So what is blockchain? Blockchain is a chain of blocks, right? Guys kind of got that? Blocks are basically stores of information about the transactions or data. Blocks have information about participants in the transaction. Blocks are identified by hashes, and the hashes are actually encrypted using the stored data. So let me show you kind of how that looks. So blocks are actually connected. You guys are mostly computer science majors. You guys know what linked lists are, right? In SQL, for example, you guys have seen linked lists, yes?
Yes. No.
No?
No.
Okay. So this is what a linked list looks like. It's a linked list. So the linked lists basically are blocks. I guess the list is a block, you would say. And each linked list is linked to the previous block. Each block holds data. This block right here is called the Genesis block. The Genesis block is the first block, and this is the only block in the whole blockchain that actually doesn't have a previous block. Everything after it actually has a block that is connected to it. So how are they connected? So if you look at the blocks here, they have indexes. They also have timestamps. They have data. And then they have the hash. The hash is the ID number of that block. They also have the previous hash, which is the previous ID number of the previous block. So how do we create this hash? So you actually use a so for example, Bitcoin uses actually SHA-256 encryption. SHA-256 encryption protocol is actually a protocol that is used for passwords. You guys know how passwords are encoded. You use some data, you use a salt, very similar concept. In order to create this hash, what we do is use this data, use maybe a timestamp depending on how you program the protocol, and we use that to create this ID number. This is a very important concept, and I'll tell you about this a little bit later, but this hash also references this hash. So they're all inexorably linked together as you continue down. This is very important because as you continue on with the blockchain, this creates a link that cannot be broken, meaning the data inside of each block cannot be altered. The blocks are all linked together by this hash, which uses the data, and they're all linked together. And so if you change one block, the rest of the chain will not function. Does that make sense? The rest of the chain will not function, and so it invalidates that chain. So this creates sort of security with the blockchain. And again, I'm kind of being general about it. I'll get more into depth with it, but I hope this kind of concept kind of makes sense. So again, this is another illustration. As you can see, there's transactions. These go into the hash value, and then this creates the hash. The hash is then linked to the other blocks. So what are the general applications of blockchain? So generally speaking, recording transactions. Recording transactions will open up transparency about data and the transactions. This recording of the transactions in blockchain reduces friction for business transactions because you no longer have to deal with intermediaries. You have to wait. Everything is semi-instantaneous. It reduces this friction. You delete a lot of these middlemen that actually, dealing with the data, recording it, backing up, et cetera, et cetera. Allowing the tracking and provenance of movement of any assets or material goods. So one use case is supply chain management, where it's ripe for disruption because we're always tracking and managing these assets, and we have to know where these assets are. Blockchain would be a good implementation. It also securely maintains and shares these decentralized records. These records are maintained by all the parties through a distributed ledger, and the more parties you have involved, the increasingly more secure this technology becomes. So the more parties you have, the more it becomes secure. So an example of a use case that you guys may know is Bitcoin. You guys have used Bitcoin? Anybody here has used Bitcoin before? Okay, cool. So some of you guys know how that kind of works. And I'll kind of go a little bit deeper with that. So Bitcoin is not blockchain. Bitcoin is not blockchain. Blockchain is a technology. Blockchain is the underlying technology that Bitcoin uses, or Bitcoin is, in order to have this cryptocurrency exist. I'll repeat that again. Blockchain is the underlying technology that Bitcoin uses in order for it to function. Bitcoin is a peer-to-peer electronic cashless system. So what does that mean? That means without having any sort of intermediaries, I can send you money right now, immediately, with no delay, depending on obviously the chain that you use. And that's very powerful. We've officially cut out all of the middlemen, and we now can deal together. So if you look over here, and as I mentioned, the linked list, Bitcoin uses this linked list to keep a ledger. Bitcoin is not actually a thing. Bitcoin is actually a concept. And this concept is storing transactions in a ledger format in these blocks. And so when these blocks are created, these transactions are recorded into the blockchain. And if I was to send you, so to speak, 1 Bitcoin, that transaction would say, I have now less 1 Bitcoin and you have 1 more Bitcoin. But there's actually not a thing. There's no actual token. Do you guys have any questions so far? I know I've gone through a lot. It may be complex for some. It might be kind of a new concept. So if you guys have any questions, yeah.
So just in general, since you've mostly been talking about blockchain as like a way to process transactions,
Right.
is it considered like an alternative to using something like a transaction processing database?
So I'm actually going to get into it, how it's different than a database.
Okay.
The idea is that it's decentralized. No one person is actually keeping a database alive, so to speak. Because you don't have one person maintaining a database, you don't have to worry about them necessarily being hacked, because the record is being multiplied and recorded and kept by thousands of people, possibly. So if one record is being manipulated, you then can compare it to the other 999 records and say, well, this is probably not true. We're going to use the consensus of the ledger. So there's pros and cons. Blockchain is not a technology that just, hey, everything needs blockchain. Comedically, everybody says, hey, just throw it on the blockchain. But the reason is because actually not everything needs blockchain. If you're doing a transaction where maybe you're buying something and you need security, you need a third party to secure that, maybe blockchain or cryptocurrencies might not be the best way to do this transaction. Conversely, as we dive deeper into blockchain and blockchain technologies as we move forward, you'll find that there's lots of blockchains and lots of them have different functions. And now we're having cryptocurrencies that are now backed by stakeholders. Cryptocurrencies that actually can hold data. For example, if you were to put a house on a blockchain using an assay-based IRC token, for example, there are possibilities to actually attach documents to that token and tokenize your house. So somebody can actually buy parts of the house as well as receive the documents all at once. So, like I said, as we move forward, this is very, very general. There's so many rabbit holes to be had here, and there's so many kind of niche things to be talked about that it's very on a case basis. But generally speaking, the difference between a database and a blockchain is that one is centralized, one is decentralized. One has a certain amount of security in a certain aspect. Blockchain allows trustless security, basically. And like I said, I'll go more deeper into that. But generally speaking, those are the differences. You guys have any more questions? No? All right, cool. So, case study. So let me show you an example. So who here has bought a car? Okay, cool. So most people have bought a car. It's a pretty intensive process, right? You have to get paperwork, get a loan, talk to people, do things, talk to more people, make sure they call you, make sure they send money. It sucks, right? Actually, I've never done it. That's what I heard. I've actually always bought my cars used, and with cash. But generally speaking, this is kind of like the process if you're leasing a car or dealing something with a car. So the manufacturer makes a car, they record it into their database. The dealer then buys the car and then records that into their database. The leasing company then, after the car is sold or leased, they record it into their database. You can see how everybody's doing this piecemeal. It causes a lot of problems for regulation, oversight, etc., etc. So how do we simplify this process? This process can be simplified by basically decentralizing things. As you see, everybody has their own piecemeal record, and then this needs to be submitted to the regulator, and it goes back and forth. Very messy process. So this is the process envisioned with blockchain. So in this blockchain process, everybody has a node. Everybody interacts with one shared source of truth. This shared source of truth is a shared ledger and also possibly a smart contract. So as everybody creates a transaction or interacts with that car, they create a transaction and they record it onto the blockchain. Again, let's see which way are we going. Dealer, scrap merchant, regular. Okay, so manufacturer. So the manufacturer manufactures the car, they create some paperwork, they record it into a blockchain, they have one record. The dealer then interacts with that car, records various interactions as they deal with their clients or customers, records it into that same record. The leasing company also does the same thing, leasee does the same thing, scrap merchant, when the car gets totaled or scrapped, interacts with that one record. So everybody has basically a one record that's shared amongst everybody, rather than having piecemeal databases where you need to upkeep them, make sure they're right, make sure nobody is hacking them, etc., etc. As you can see, it simplifies this whole process. Do you guys have any questions so far?
So the one on the right side, is that just like per car, everything that's happened to the car is stored in one block on the blockchain? Does that make sense?
Let's just say no, generally speaking. I mean, it depends. You know, like as with any implementation, it depends on how you implement it. But generally speaking, this could be a blockchain that is on thousands of cars, and each car can have its separate channel, for example. And when you interact with that car, make a transaction, do something, buy a car part, that transaction is recorded specifically for that car. But the blocks could segregate. So blocks, again, depending on how you structure it, in Oracle blockchain, you can actually set up the timing and the size of the blocks. So if you have 5 transactions and the block is 5 megabytes, and each transaction is 5 megabytes, that'll be 5 blocks, right? If you say it's 25 megabytes, and each transaction is 5, so it would be 1 block. These are private blockchains. I'm going to get in that in a second. In public blockchains, for example, like in Bitcoin, I believe it's every 10 minutes a block is created. And so every 10 minutes, everything that fits into there goes in that blockchain, or into that block. So it's a store, and then there's different types of ways of searching for it, et cetera, et cetera. And I'll get into that in a second, the difference between private and public blockchains. Any more questions, guys?
Can you edit like an existing block, or do you have to make a new block?
You cannot. That's the whole premise, is that it's immutable. The records are immutable. So with blockchain, you kind of have to think a little bit differently. You have to think, as Alex mentioned, he was asking about the difference between databases and blockchain. You have to think a little bit differently. You are no longer editing a specific variable on a database. Every time you have to make a change, you create a new record of everything, of that specific record. And that's what makes it immutable. And that's what creates the history on blockchain. And that's why I was talking about the linked lists. You can't unlink something. You can't go back and change it. So for example, if you were to make a record of the car and you screwed up maybe the VIN number, you have to recreate it, what you would say is that record is now closed. You're opening a new record for a new VIN. But the record still resides that you screwed up and you created a bad VIN. Make sense? Yeah. Yep.
Where you said, I mean, the picture says node, right? Are those physical nodes, physical servers, or?
Yes.
How does the physical node?
Yeah, so everybody actually owns a node that resides on the blockchain. A node could be anything that accesses the blockchain. And I'll show you an example in the hands-on examples. I think it'll make a little bit more sense. But everybody owns a node, and that node is the interaction or gateway in order to interact with the blockchain.
So each individual node contains all the records of the blockchain, or the
yeah, so
just
everybody,
information about that?
so depending on, and I'm going to go into private and public blockchains, depending on the type of the blockchain, you have access to the data. And the way that data is structured is dependent on the blockchain, but everybody actually owns a record of all of the data all the time. But your access is either granted or you have to have permissions in order to access that. Something like Bitcoin, publicly accessible. You can actually check everybody's balances anywhere, anytime. That's what makes it cool, but that's also what makes it dangerous. Because if you own 100,000 million $100 million worth of Bitcoin, somebody can actually see that. And that's cool because nobody has to verify the amount of money that you actually own on that specific account or that specific address. But on the other hand, maybe you don't want people to know that you have $100 million on that account.
That's not good.
Yeah.
So if everyone owns a copy of the transactions or everything throughout history that happened, wouldn't that be very memory inefficient?
Not memory.
Storage.
Storage, yeah. So like I said, we have a lot of different blockchains now.
Yeah.
We started off, primarily, I think you guys probably were introduced to blockchain technology through Bitcoin. And that is kind of like the oldest, most well-known technology. And yes, that record can grow up to, I think it's something like 50 or 100 gigs now. And it's going to continue growing. So yes, it's very kind of like storage, possibly inefficient. So a lot of people have actually come up with a lot of different other blockchains to create ways to store more efficiently, more effectively, using different protocols. And also there's something called pruning. When you create a node, you actually you receive a copy of that blockchain, and you go through the blockchain and you verify it up to a point. And then after that point, you don't need to verify it because you've already verified it. And so you start from like an alternate point 50 gigs ahead. So you don't need that 50 gigs. And so also there's a way to verify it without actually storing it. So you can have main net nodes that actually have full copies of the blockchain. And so what you do as a participant node, you can connect to these, you can verify that all the transactions are correct, but you don't actually have to store it. Sort of like, kind of just maybe streaming like a piece of that interaction first and like verifying it, putting it back. Verifying, put it back, and then up to a point you know that everything is verified.
Okay.
Okay. So there's a couple of different things going on there. You guys have any more questions so far?
But you could download the whole blockchain.
Absolutely. At any point in time, again, depending on the type of the blockchain that you're using, yes, you can download the whole.
In order to decentralize, that's the point, right? You want
Exactly.
You want to
Yeah.
download everything.
Exactly. That's the whole point. Everybody has a copy of the
whole blockchain.
of the record of the blockchain, and everybody knows what's going on with it, can verify it, and if something is wrong, they can then kind of compare and contrast to consensus based on their records. Making sense so far? So cool? All right. So another slide just showing about how blockchain will transform supply chain management. It's a single source of truth. It reduces problems or processes, and it creates more efficiency because, as I mentioned, everybody has a copy of the record. It's decentralized, distributed all the time, and everybody can interact with that. So things such as accuracy in cost information, provenance, reducing human error because things are automated, automatically recorded, reducing counterfeit goods. I actually worked on a project where we actually talked with some supply chain management clients, and we used an example where Nordstrom's was trying to create a blockchain-based solution that they could sell goods and services, goods like shoes, bags. They can confirm the whole process of manufacturing to selling, and then the client can actually use an app to look up that QR code, that SKU number, and verify that it's actually not even fake. So it's really, really cool. So you were asking how is this data different than databases? So database is centralized. Somebody has to keep it. You guys are in the cloud. You guys know about disaster recovery, servers, on-premises solutions, right? All that. Well, it removes all of that basically. Well, not the server part. You still need servers. You need nodes. So what's cool is that everybody has a copy of that record, and that record is always reconciled amongst everybody. Every time you make a transaction, every time you make some interactions with that blockchain, you're always reconciling it. You're always checking it.